Hello everyone. We have been discussing about the different built-in agents that AutoGen has got to offer. Few of which are the user proxy agent, the assistant agent, as well as the group chat manager. In the past, we have dealt with implementing an agentic workflow by creating a user proxy agent as well as an assistant agent. That is a two-way messaging service or two-way chat, where user proxy agent acted as a code executor and the assistant agent acted as a code generator. As you can observe, this assistant agent is tightly integrated with the large language model, where it's leveraging the large language model to generate the code for a given problem. For a given problem, we basically make use of this assistant agent to generate the code, and user proxy agent executes whatever code that's generated by the assistant, tries to find if there are any issues, and then probably go about fixing them as well. If you observe carefully, the different inputs for user proxy agent is provided here. Like, it also expects this additional parameter called as human input mode, where the user will be allowed to provide any input explicitly in between the messaging. So human input mode can either be set to never or always or even terminate. We also have understood the clear distinction between all these values, all these possible values for human input mode. Okay. If at all we are providing additional feedback or input in between the messages, we are basically altering the environment that's associated with the agentic workflow, and we are defining the way in which the environment alters as well. Okay. Anyhow, we have not dealt with the group chat manager yet. So both user proxy agent and assistant agent extended from both are extended from conversible agent, which is acting as a base class here. All the attributes and methods associated with conversible agent are now being accessible by both user proxy as well as assistant agents. Whereas the group chat manager is not extending from the conversible agent. It's not getting extended from conversible agent at all. However, group chat manager typically acts as an orchestrator, which will prioritize the given set of agents that you are having and get the problem solved. Let's say that we are dealing with a complex problem. We are dealing with a complex problem which involves multiple agents, not just a couple of agents. So there are four different agents that are pictorially represented here. So group chat manager orchestrates all these different agents and try and come up with a solution for the given problem. The group chat manager typically selects what could be the next speaker among all these agents. So it selected agent B to be the next speaker. Agent B actually sends back or relays back the message to the group chat manager. After receiving the message, group chat manager broadcasts the same message to the remaining agents. So all the agents are context aware, right? So all the agents has got the information at every single message that is actually happening in the whole agentic workflow execution here, right? So once all these three different steps are done, again, the group chat manager selects which the next speaker is. It might select the next speaker to be agent T. Group chat manager is now acting as an orchestrator, which typically prioritizes what agent to call when. Okay, it has got that ability. So it's also integrated with large language model to get that reasoning defined for it. There are multiple other ways in which the group chat manager will let it determine what could be the agent to call in the subsequent iteration, but it can also be coupled with large language model for reasoning to understand which agent to call when. Okay. So this is on a pretty high level. Now let's look at considering a problem, like let's try to develop a Sudoku game, Sudoku puzzle to be more precise, and also provide a solution. So we basically are now creating multiple agents, and we'll also create a group chat manager, which again acts as an orchestrator and tries to interact with all of these multiple agents that we create for generating a Sudoku puzzle along with the solution, and finally come to a conclusion, which is nothing but a solution. We just present back the solution along with the puzzle back to the end user. So there could be multiple agents here if at all you are planning to develop a Sudoku game, right? So the very first agent that comes to my mind is the Sudoku generator, the Sudoku puzzle generator. And the other one could be solver, that's to provide a solution for the given puzzle. And another one could be verifier, It basically verifies whatever solution that's provided by solver and tries to understand if it abides to all the given Sudoku rules or not. And Agentic can just be a visualizer. So it may basically generate a visually appealing result back to the end user, or probably the Sudoku 9x9 puzzle along with the solution needs to be presented back to the user in a more visually appealing manner. And that's the job of this agent, which is a Sudoku visualizer. Okay? These could be 4 different agents that we might end up creating. And we'll also create a group chat manager which will interact with all of these different agents that we have created and get the problem solved. Like finally, we should be able to provide or generate a Sudoku puzzle depending on the difficulty level selected by the user. It could either be easy, medium, or hard, and also present back the solution to the end user. Let's try to practically implement all what we have discussed so far in VS Code. Okay. Let's get back to this coding exercise where we first import the OS module. We are importing OS module in order to access all of these environment variables that I've defined. So I have extracted the API keys for GPT-4o model, GPT-4o mini, as well as DeepSeek models. And the base URL is being set models.inference.ai.azure.com. I have created a separate video for you to enable a clear understanding on how I have derived all of these keys and how I can access these APIs for free without any cost. Okay. So now from AutoGen, I am going to import all these different agents, the assistant agent, the user proxy agent, the group chat class, and the group chat manager as well. So once we import all the necessary classes, we are also looking at importing load underscore dot env because I'm looking at loading all the environment variables to the session by invoking this function called load underscore dot env. I'll also set the model to be GPT-4o mini. Okay, this is a model that I'm planning to consider as large language model for different agents that I'm going to create, for which I need to also create a LLM config. So the LLM config will have multiple parameters, one of which is going to be the model. The other one is going to be the API key. API key basically is accessed by this environment variable, OpenAI mini key, right? So os.environ.get and provide the variable name. And let's also provide the base URL here. The base URL can also be accessed in a similar manner, os.environ.get, and just provide the environment variable here. Okay. Along with this, we also can set the temperature. So setting the temperature to a value of 0 does indicate that all the LLM responses that you are expecting has to be completely deterministic in nature. Along with this, we basically can also try to set an additional parameter called as price and provide a value of 0 in a list here. I'll let you explain, or I'll probably explain about this particular parameter much later in this session, but not now. But please remember, few versions of AutoGen will expect this parameter to be present in LLM config, and hence I have provided this because I'm just using the API or doing the API invocations for free, where the price associated with each invocation is going to be 0 here. I'm just explicitly stating it here. Once the LLM config is set, let me create this user proxy agent, and the name of this particular agent here is going to be user itself, since this is a user proxy agent with which we'll initiate the conversation as such. And we also have understood that we would need to provide this human input mode. So I'm just providing the value to be terminate, which indicates that the user will be allowed to provide an input at the end of code execution. Along with this, I'll also provide code execution config, which typically involves what is a working directory here. The working directory here probably will be a user defined name like what I'm providing now. And use Docker is yet another parameter for which I'm setting it as false because I'm not using any Docker here. Okay. So once the human input mode and code execution config parameters are set, let's also define the LLM config that we have defined in the previous step. Okay. Cool. So once the user proxy agent is being set up, now let's go about defining the very first agent, which is going to be the Sudoku generator. Okay. We'll also define the roles of every individual agent that we are going to create while creating these agents itself. So all of which are nothing but assistant agents itself. So the name of this particular agent is going to be Sudoku generator. Sudoku generator. And I'm going to associate this with a particular object name called as Sudoku underscore gen. I'll also provide a system message where we'll define the role of this particular agent. So you are responsible for generating a valid 9 cross 9 Sudoku puzzle based on the difficulty level provided by the user, which could either be easy, medium, or hard. Okay. So this is the job of this particular agent. And once we have set the system message, which is the instruction for this particular agent, let's also provide the LLM config here. So LLM config will be LLM config. And the second agent that we are going to create now is going to be Sudoku solver agent. Now I'm going to update this name here to Sudoku solver. And this agent is responsible for providing a solution to the given 9 cross 9 Sudoku puzzle. That's all. Let's get rid of all of this text and probably update this particular object name to Sudoku solver. And once this is done, let's also create an additional agent, which is the Sudoku verifier. Okay. Sudoku underscore verifier. And let's also update the name of this agent, and let's also provide the system message stating that you're responsible for verifying the given solution. Verifying the given solution for 9 cross 9 puzzle. Okay, given Sudoku solution. Let's explicitly state what solution it is. Okay. Please consider all 9 cross 9 Sudoku puzzle rules while verifying. So we need to state this explicitly so that it's going to consider all the rules and it will check if the solution is abiding to all of those rules or not. And there's yet another agent, which is the visualizer agent. And let's update this name to Sudoku visualizer. Sudoku underscore visualizer. And let's provide a system message stating, asking to generate a visually appealing Sudoku puzzle along with solution to the end user. And that's it. There you go. So we basically have created these 4 different assistant agents. The very first one here is Sudoku generator, which generates the 9 cross 9 puzzle. Sudoku solver provides a solution for it. Verifier basically provide or validates the given solution. And finally, we also have this visualizer, which will generate a visually appealing Sudoku puzzle along with the solution back to the end user. And now let's define this group chat. So group chat here basically acts as a channel for which all these agents will leverage for exchanging the messages, right? So we need to define the set of agents here. What are the different agents that we have created so far? The agents that we have created so far basically are the user agent, the generator agent, the solver agent, verifier, and visualizer agents. Let's include all of these different agents that we have created so far in the list of agents which needs to leverage this group chat for exchanging the messages, right? So what are the initial messages that we can have? So nothing, just providing an empty list indicating that it's a clear channel. So we do not have any default messages to begin with. Okay. So once we have created this group chat object, now let's create the group chat manager by making use of the group chat object that we have created in the previous step. And along with this, we need to provide LLM config. That's all. So let's call this as group chat underscore manager. Okay. So now let's use the user proxy agent to initiate the conversation, to initiate the chat. Obviously, we need to use group chat manager, which internally points to all the different agents that we have created so far. Let's also provide the message. The message here will involve the content which describes the problem here. So what is the problem that we are trying to solve? So we are trying to generate a Sudoku puzzle, and we are trying to generate a Sudoku puzzle and solution as well, a valid solution as well, and also visualize it back to user. Okay. So this is the overall problem that we are trying to solve. In this interpolated f string, let's also provide the difficulty level here by making use of a particular variable called difficulty. Let's define a function as such. Function here could be play Sudoku. And obviously difficulty is going to be the parameter here, and the default value that I'm going to set here is going to be easy. Let me indent this block of code, and thereby we have created this particular function definition. And now we can invoke this particular function with a particular value for difficulty level. And now whatever initial message that we are having while initiating the chat with group chat manager basically will help the manager understand what's the problem here. Along with this, we'll also provide a role, the role of this particular agent. The role here is going to be user itself, since this is a user agent that we are leveraging. And that's it. So we basically have done all the setup, and there is one caveat here. So you know that I have been using free API calls, and there is a specific rate limit associated with every key that I'm going to generate. Okay. So obviously, if I let the group chat manager determine the next speakers, it might end up iteratively conducting that exercises, and also in turn explode the number of API invocations that we do till we generate the solution. So in order to avoid that, I would want to explicitly state what agent to call right after generating the puzzle. So right after generating the puzzle, I would want the manager to call solver, because I do not want to let the group chat manager determine what agent to call next because of the rate limit criteria that I'm having currently for the API invocations. Okay. I believe you have understood what I'm trying to explain here. So I'm explicitly stating that after generating the puzzle, explicitly call Sudoku solver. And for Sudoku solver, I'm also mentioning after generating the solution, explicitly call Sudoku verifier. And finally, for verifier, after verifying, explicitly call Sudoku visualizer. That's it. So we now have all the setup done. Let's highlight all the code, try to run this particular code and try and understand if it works properly or not. So now the very first message here is from the user to chat manager, asking to generate a easy Sudoku puzzle. So the next speaker that the group chat manager determined is Sudoku generator. And obviously here's a Sudoku puzzle that's generated, and it's also provided a valid solution. But it's the job of solver to provide the solution. It's not the job of Sudoku generator. And hence the chat manager determined the next agent here should be solver. And obviously it tries to generate a valid solution. And then the subsequent speaker here is going to be the verifier. The verifier validates all the Sudoku rules for the given solution, and it identified that there was some invalid rows. So the conclusion here is the provided solution is invalid due to multiple repetitions in rows. And hence it goes back to Sudoku generator, asks it to generate an alternate Sudoku puzzle because whatever solution that was provided earlier was not correct. And it again invokes Sudoku solver to provide a valid solution. It invokes Sudoku verifier again. It tries to validate. This keeps on getting repeated until it tries to find a particular 9x9 Sudoku puzzle with a given difficulty level and a valid solution associated with it. If you observe the final visualization that's presented by this Sudoku visualizer agent, we clearly understand that this is a Sudoku puzzle that's being represented for the display purposes. And we also have the solution that's being represented. And whatever solution that you are currently observing is a valid solution, which is being verified by Sudoku verifier agent that is part of the group chat here. Okay. So this is how you basically can work on a particular problem and try and explore different options like creating multiple agents, assigning a role to each and every individual agent, and create a manager to inspect or to orchestrate these different agents and get to some conclusion or solution for the given problem here. Okay. So that's pretty much all I wanted to discuss with you in this session. Thanks for watching.